Hello and good morning, good evening, good afternoon, and thank you for joining to this Neo4j live. Today, topic is solving GraphQL challenges with 3Edges, and I'm with Alex Babianu from 3Edges. So welcome, Alex, and thank you for joining.
Hi guys, thank you for having me. Glad to be here.
Great to have you. So the topic today is going to be solving GraphQL challenges. So it's almost like a little GraphQL week or episode here and on the channel. So we have since a couple of weeks we have a book club with my colleague Will Lyon on his GraphQL full stack applications book. Which I'll post in chat here. I don't know, Alex, if you read that book or if you had a look at it. It came out earlier this year.
Yeah, I did peruse through it. Actually, I could download the PDF. Thanks for sharing that, you guys. Yeah, some interesting stuff in there for sure.
Yeah, cool. And today you will show us a bit about how to solve GraphQL challenges. So when we talked about this earlier, GraphQL is if you don't know what GraphQL is, it's an API language that's very successful at the moment. Lots of adoption is growing, particularly across the developer community. And if you are working with it a little bit, you realize that it all seems so easy, but then some footfalls come around, and then you need to solve problems. And how did you write it, Alex? To say how to prevent queries from bringing the backend services down. So I guess that's like
Yeah.
So we don't want that. So that's clearly what we don't want. But before we dive in, maybe Alex, do you want to give a short intro about who you are and what you do?
Yeah, sure thing. I'm the CTO at 3Edges. We are a startup. We built a platform called 3Edges that can generate, without writing any code, GraphQL API service microservices that you can use as APIs, but as well as authorization services. My background is from identity and access management. I was a consultant for 10 years on the field of solving identity and access management and security problems for clients. And before that, building identity and access management solutions for as a developer for big companies. I was a principal at Oracle and PeopleSoft before that. So worked on the OIM product and the PeopleSoft directory interface and things like that. So as you will see, 3Edges is a GraphQL generator, but also has a strong focus towards digital identity and authorization.
Cool. Yeah, that makes sense. It's a very interesting topic. As lots of funny coincidences today. But yesterday, Michael and I, we had in our live stream, we had talked about AWS services and how to integrate more or less like a network, a services or a software infrastructure, a digital twin of your software infrastructure within Neo4j. And that obviously creates dependencies. An application can have dependencies inside your local or cloud-based environment, but also outside into the AWS services. But then again, it also has dependencies on users, on access, read and write access rights from users out from the developing team. So it's like a huge a cloud that builds around, or a flower almost, like around any point in your stack, built upon from microservices to a big full-fledged application. That at any point of time, I don't want to say it can fall apart, but a little thing that is maybe not set right correctly, or can lead to disaster almost, or at least to major headaches. So
yeah, for sure.
Yeah, it's good. How did you come across into the world of graphs? How did that journey happen?
So that's interesting. Like, this was actually already a few years ago, back in 2014. I was looking into some problems that were a bit complex, and relationships were key to it. I was looking, with standard tools, and then a colleague of mine, Dave, actually showed me that hey, you could solve this using graphs, and that's when I dove into it. Interestingly, at the time, the consulting firm was working for, they're still around, great company in Nolly,
Mm-hmm.
identity management. They partnered with Neo4j since,
Mm-hmm.
and we started working with graphs for clients, in particular in the IoT sphere, in the insurance sphere. All of they had, for access management, they had very complex use cases that we couldn't solve with standard IAM tools. Like if you put everything in an LDAP directory, everything is hierarchical. That's just one type of relationship,
Mm-hmm.
parent child. But as we know, we need more than that.
Yeah.
Um, and that's how it kind of evolved from there, really.
Oh,
And
cool. Yeah.
we started building this app, and now 3Edges is kind of the encapsulation of all this knowledge that we gathered over the years, really.
Cool. Yeah. That's a nice journey, interesting journey. How many people are you now in 3 Edges?
Well, it's we just started. We released during Graph Connect this year, actually,
Mm-hmm.
and there's let me think, seven of us now.
Cool. Yeah. So yeah,
Yeah.
it's small and nimble, I would say. Yeah.
Yeah, but we're it's the product actually has been live in production. We've released it this year, but it's been live since last year, so
Yeah.
it's
Okay.
pretty stable. Um, so yeah, we start to see some traction, so that's good.
Yeah. No, I'm very interested to see more. Very eager to hear about it. Just before we dive in and I switch over to your screen, excuse me, I just wanted
Sure.
to make one comment that I always make. This is obviously live. This is um, well, if you watch this later on, it's not live. But if you watch this now, right now, at this point in time, it's live. And because we are here, Alex and I, so if you have questions, if anything comes across your mind, we say, okay, can you elaborate a little bit more on this or that, particularly on what Alex is showing, then don't be shy and use the chat. Type it in, and I'll try to filter for Alex a little bit. But if we have time, we can read through most of your questions, I think. And
Great.
yeah, that's what I wanted to say beforehand. And now I can switch over to your screen, Alex.
Sure. Just one
Yep.
thing, Alexander, if you could help me here, if I'm in full screen, I will lose sight of the chat and everything. So if you have questions, if you
Of
could just
course,
voice them.
yes, yeah. I will read out
Perfect.
questions as they come in. Don't worry.
Perfect.
Okay, here we go. Oops.
All right.
This
So
is
I've
one.
already introduced myself. So what to expect from today? I'm going to show you some slides, and we'll talk about GraphQL, why there are what it is. I mean, if you don't know GraphQL, I'll give you a very quick run through it. Just a couple of slides, and we'll have a look at the problems that arise with GraphQL, because there are
Mhm.
some problems. You can read a lot about it online, and we'll have a look at those. We'll have a look at the solutions. And last but not least, we'll look at 3Edges and how 3Edges can help you solve those problems and get you started on that journey. Hopefully that sounds all right.
Sounds very good.
Uh,
Yeah.
so first of all, the legend. I mean, we all know the lore and story of GraphQL. It all started with Facebook back in 2012, right? And then they released it in 2015. But it's interesting to see why Facebook started GraphQL. So back in 2012, it was already the biggest social network out there with those numbers. 1 in 5 of every all page views, almost a billion users, 100 billion connections. But what was interesting in 2012 is that it's the year that they really started to want to make money out of their social network.
Yeah.
And you can see some headlines as this one. They decided to actually start selling advertising through their newsfeed. But the problem was that their main drive, I mean, the main channels which they wanted to do this was, their iOS and Android app, which was actually very slow and was suffered by a lot of crashes. So they had to do something about it in order to achieve the goal of, selling advertising. At the time, their app was just a thin layer over their website. So it was just a thin layer over HTML views. They did this so that to not duplicate code or to minimize the amount of code they needed to write. Well, it didn't work very well, as we've seen, lots of crashes. So instead, they decided to write a dedicated app and write their own APIs. So first of all, they started, as everybody does, writing REST APIs. But they discovered that the data required by the client app was very different from the data from the necessary queries that you needed to run in the backend to load that data. They had to write way too much code on the server side to prepare the data and on the client to parse it. And then there was this realization, and this is a quote from Lee Byron, who is currently the GraphQL Foundation director, and he was an engineering manager at Facebook back in 2012, and he's one of the co-authors of GraphQL. His realization was that we don't think of data in terms of resource URLs and secondary keys or join tables. No, we think about it in terms of graph objects and the models we ultimately use in our apps, such as NS objects if you're in the iOS world, or JSON. And that's kind of a paradigm shift, because REST is a server-centric standard and paradigm, whereas GraphQL, as we'll see, is a client-centric paradigm. And that's really the breakthrough that happened in 2012. Maybe not as dramatic as this, but it seems relevant somehow.
That's good. That's very good. I like this. This is very, that's good.
So they rebuilt this app. They invented GraphQL, and they built this brand new mobile app using GraphQL. And now you see, and the headlines were like, Facebook launches speedy new mobile app. And as you can see, advertising in the newsfeed. Thanks, Facebook, for that.
Finally.
Yeah, and great results, all up to 50% more click-through, 8 to 10 times more reach. And they were so happy about it that they felt generous. I guess 3 years later, they released it for us to use. And that's how we have it now. This is actually the article that released it, authored by the same Lee Byron. If he's watching this one day, thanks for that, Lee. I hope to meet you one day.
Thank you, Lee.
So why GraphQL then, based on all of this? Well, as we've seen, GraphQL is client-centric and enables a client to request data in any desired way. So that's super powerful, and it explains the adoption of the language. It reduces coding. It provides us the ability to use graph objects on any type of backend, really. But as we'll see, it makes more sense to use a graph database. And last but not least, it avoids the age-old problem of overfetching. As you know, with REST APIs, you kind of are limited to what that REST endpoint returns to you. And more often than not, it returns more data than you actually need. Great, so that's a great idea. So moving on, what is GraphQL? So this is where I have just a few slides about GraphQL in case you're not super familiar with GraphQL. If you're watching this later, feel free to fast forward. But anyway, GraphQL is a language for APIs on the web. So instead of, like REST, hitting any number of REST endpoints, you just hit one REST endpoint. And that REST endpoint, you post to that REST endpoint with a body, and that body contains GraphQL language. And so the way it typically looks like is you have a client that packages a request of some sort, for example, a query. The server understands the request, makes calls in the backend using any language to a given data store, and then responds using a JSON response that matches the layout of the request. So that's kind of a very high level how that works. And for this, the magic happens on the server side, where we define a schema. A schema is kind of a text description of types that the server supports, and we'll see some examples, as well as queries and mutations. The queries and mutations are just in the schema are just definitions, if you will, and you need to implement them via special functions that are called resolvers. Those resolvers can be implemented in any language you like, for example, JavaScript, very popular, or Go, or what have you. And those resolvers actually interact with the database or databases, because you're not limited to just one single data store. You could conceivably use many stores to fetch the data and then return it to the client. Great. So let's have a look at a quick example here. Here's, for example, a schema in which I define a user type with some fields, user, username, email, password. Great. Now, on that schema, we're going to augment it by adding some mutations. Mutations are functions that allow you to update the data. For example, I'll have a mutation to create a user, to update a user, or delete a user. Pretty simple. The schema only contains the definitions. And as I said, the resolver's task is to implement that. And we'll define a simple query. For example, this query here takes in an input parameter for pagination. Well, I don't have to deal with that now, and returns an array of users. Great. So using that example, we're going to now see how to implement relationships in GraphQL. Let's add another type to our example here, a device. Now, a device has a name and a device ID. Let's say I want to manage a user's devices. So now I'm going to augment my user type with with an extra field here that is actually a relationship that points to the device type. It's kind of this jargon here, but essentially what it says is that I have a set of devices, which is an array of device, points to this, and it's a relationship of type owns. So in effect, what I'm doing here is I'm implementing this relationship. User owns device. Pretty straightforward. Given that, in GraphQL, I can now make queries. For example, if I wanted to get a user's devices, I can simply make a request like this. A user, I want to fetch the first 10 users, and I want to get all the devices that the user has. And the response can be something like this, for example. This is JSON, and as you can see, the format of the output matches the format of the query, which is what I want. And for example, here, this user has one device, and this particular here, Bob, doesn't have any devices. That's it. Pretty cool, right? We just define types, and then we can run any query.
Yep.
Cool, but like with
there was a but.
like with anything, there are a set of issues which I'll go through in the next slides. So there are various issues. Some of them are more development related. Some of them are based on security. So starting from the top, there are many issues that you can read about, but these are kind of the most common one that you encounter or that people are concerned about. Some people even say never put GraphQL on the web, it's a bad idea, etc. And because of these things. So the first one is N+1 queries. A lot of people complain about GraphQL performance, and typically the main culprit is so-called N+1 queries. So what is it? This is where your resolvers do N+1 round trips to the servers in order to fetch the data. For example, if you wanted to return a user's addresses, and if you were to fetch do one match, say, to get the user, and then and do other n matches to get all the n addresses of the users, then you suffer from the N+1 problem. Is another way it could look at if you're using a SQL database. If you have to use one select to fetch the user and then one select to fetch the address of user one, another for the address of user two, etc. That's the N+1 problem. How can this come about in GraphQL? Well, in nested queries. For example, the first one here, the first resolver would fetch one user, and then you'd have n queries for n addresses for that user.
I see. Yeah.
Same thing here, author and books. Here again, depending on how you're implementing your resolver, you could get N+1 queries here. Hopefully that's kind of obvious. So what can you do about it? Well, first of all, try and write type resolvers. It's better to parse the relationship from the top down instead of being so granular that you have to run your request, your cipher or your SQL at the field level. A second solution that is probably even more recommended and kind of the typical way to solve this is to use a data loader. So a data loader is a special type of function that does not return data, but returns a promise to the data. So it's an asynchronous object. So, and then you have to deal with this delayed response, if you will. So what that allows you to do is to batch the requests and to ensure that in that batch, you can actually return everything in one shot, if you will. There are actually open source data loaders that you can use. For example, Facebook actually created data loaders and opened them. I think the one I mentioned here in this link is one of those. So data loaders, and being very careful on how you load the data is super important to avoid the N+1 problem. What other problems do we have? Well, change management. As we know, with REST APIs, what you often see is that when a REST API evolves over time, people create different versions of it. So like if you make a request to a REST endpoint, you'll have to hit version 1.3.5 or whatever of that API. And when you're ready to upgrade to the next version, then you can do it. Well, not so in GraphQL. How do GraphQL when GraphQL schemas change over time? Well, how do we do that? How do we ensure that we don't break client applications when we modify types of fields or delete type of fields? Well, the solution is we don't do versioning in GraphQL. The GraphQL best practice and recommendation is instead to use the deprecated annotation. Annotations or directives are little tags that you can add to your types or fields, and they are actually understood and enforced at runtime by your GraphQL server. So here's an example. Let's say that we have a type called myType, and we have an old field and a new field. The old field is now deprecated, and here's another deprecated field. We can add a reason for the deprecation of the field so that whenever a client uses this field, they also get that message. Now, if you started to monitor the usage of those deprecated things, you could actually remove them once you see that no clients actually use them anymore. So it could take time, but that's the recommended way for doing this in GraphQL. So versioning, interesting one.
Yeah, that's very interesting because I think, you are not. This does not come by intention. So very out of habit. I think you would do versioning instead of this. Yeah.
And you can, and that's actually there's a lot of best. I mean the best practices of GraphQL. I mean you can find them online. That's the recommendation, and actually it makes sense. It's really hard to maintain versions if you've never done versioning. It's not a fun thing to do. So this is much easier.
Yeah.
Another problem is deep queries. What is it? Well, it's visual. Here's a deep query. So what's the problem with that? So this is actually quite important.
What's the problem with that, Alex?
Right. Anyone? Well, obviously, if you have a gazillion users, this can easily break down your server in just one shot. So this is actually a big issue. It could be a security issue in that if you don't restrict access, at any level, you can leak more data than you intend to. And also, a malicious client can actually bring down your whole service just with one single request. So you can't throttle your GraphQL endpoint like a REST endpoint because one request is sufficient to bring it down. Instead, what can you do? Well, you have to do, if you really want to make sure your GraphQL service is ready for the internet, you have to do query cost analysis. So what that means is that before you run the query, you have to assign it could be arbitrary or whatever, but you have to assign a cost for every operation or every level. There are various open source libraries out there that can help you do that depending on the language, but you can implement your own scheme. For example, here at the first level, my cost is 10. I can say my cost at the second level is 100, and so forth. And after a while, I get into these kind of orange area where I have to decide whether I run this query or not. But after a while, I'm sure I don't want to run the query. Like if I reach the 100,000 or million cost, I'm like, I'm not running this query. So this is something you also need to do, to publish your GraphQL API on the internet. All right. So another problem is so-called the object relational impedance mismatch. So big word, but this one is actually probably one of the main reasons you should use a graph database with GraphQL. And this problem arises from the fact that you're using a relation model on one side in GraphQL. And if you use something that is not relational or not as relational on the back end, you end up with all kinds of problems. Like in GraphQL, you can have inheritance, for example. How do you do that in a SQL database? So you have all kinds of problems that you have to deal with in your resolvers. But if you're here, you probably use a graph database, and this problem is mostly alleviated with using graph backend because it matches much more closely the GraphQL schema. Hopefully that made sense.
Mm-hmm.
All right, so now last but not least, and this is a big topic, it's security and access. From my experience in the field, I've noticed that developers hate to do access management. It's usually something that is done after the fact as a band-aid. The end result is something that is kind of holds up, but not really. Open standards are sort of used, but not really. Anyway, so it's as important with REST as it is for GraphQL. But we'll see for GraphQL, the challenges are quite different. So first of all, what am I talking about here? There's two things. There's authentication and authorization. So authentication is it's like the main gate to your castle, is where a request comes in. You want to know who makes the request. You want to authenticate them. Usually what happens at that point is the subject or the user trying to make the request goes through some kind of authentication process like login or multi-factor authentication or what have you. The end result of that is that we know who they are. Okay, great. So once we know who they are, well, this is where authorization kicks in. What can they do? All right, so we know it's user Alice. What can Alice do? Can Alice access everything? Or what can Alice not access?
Yeah.
So, for example, given this simple model up here where we have a user that has a permission to write over an account, a bank account, say. Now, if I made this request, there I'm going to show you two types of access requests. This is type of access request one, where a different user, say user Alice, tries to get a list of all the users and their bank accounts, for example. Maybe for a report, maybe she wants to hack the bank or whatever. So first, we want to authenticate the user who makes the query, right? So this is the authentication part. Who is asking? Alice is asking. Okay, great. So now we know it's Alice. So can Alice access all the users? If she can, which users can she or cannot she access? What about the permissions? Can Alice access all the permissions? And what about the accounts? Can Alice access all the bank accounts? So what about the account ID or some specific fields of that account? Can she access everything? So as you can see, authorization can happen at any level and can be enforced pretty much everywhere, really. Here's another type of access question. This is a question where the user Alex here tries to log in and access their own bank account. So here the question is, can this user access this bank account? So we're not getting a list of responses. Instead, we're getting a decision, yes or no. And to solve that request, we use what we call relationship-based access control. For that, we will look for the path between the user and the resource they're trying to access. So those are the types of questions we need to ask ourselves when we build a GraphQL API. So the solution here for authentication, it's like REST, use open standards, OpenID, OAuth2, and typically you have to validate an access token, which is supplied as an authorization header. Great. For authorization, though, what we are provided with is the auth directive, which can be placed on types as well as attributes or properties, and which can be used at runtime by the GraphQL server to enforce some kind of authorization. The auth directive is actually a function that you can implement in any way you want. In this example I'm showing here, I'm defining the directive in the GraphQL schema. This directive here takes a requires attribute, input parameter, and the default is admin. The input requires is a role here, and it can be applied to objects or fields. So here's, for example, how that can be used. I've got a user type, and in order to access this user type, I need to have a user role. But if I wanted to access, say, the user name, I would need to be an admin. That's kind of a high level how you would implement auth. Because the auth can be placed at any level, on any type or field, it will be triggered at any level of your graph query.
Interesting. Mm-hmm.
So to summarize, the pains we looked at, the N+1 query problem, which leads to poor performance, security issues which linked to deep queries, and those are you could be subject to data traversal attacks or denial of service attacks, and also granular access control. We just talked about that. The object relational impedance mismatch, which greatly alleviated with graphs, change management, use the deprecated, and also last but not least, the learning curve with GraphQL. And if you didn't know about any of these pains, you might stumble upon them at one point or another. So given that, this is where I'm going to start to talk about 3Edges then. So given all these pains, how can 3Edges help you? First of all, what is 3Edges? I kind of talked about it a little bit, but 3Edges is a no-code authorization server generator. It's actually microservices, but it's also a GraphQL API generator. So the way this works is 3Edges is actually a cloud platform. You go on the cloud and you define a graph model. Once you're happy with your graph model, you can then auto-deploy and generate a set of microservices. So for every API that you generate in 3Edges on the platform, we deploy 3 microservices. The first is the API server itself, but along with it, we also deploy an authentication service as well as an authorization service. The authentication service is just there to get you started as a helper. It's a fully fledged OpenID Connect identity provider, so you can do OpenID with it and log in with it. But if you need something more fancy like multi-factor authentication or different user journeys or stuff like that, we also support external providers as long as they are OpenID Connect. We definitely use open standards, so that's what we insist upon. Anyway, the last one is the authorization service. That is our implementation in our own engine that understands fully fledged relationship-based access control. And I'll show you that in a bit in the app itself. Of course, this API server works with a graph database as a backend. So here you bring your own database. 3Edges doesn't store any of your private data. You have to bring your own. We only store configuration and metadata. If you don't already have a graph database, thankfully, you can easily get an Aura database. We'll talk about that briefly. Mm-hmm. You just plug it in, and you can use it right away. Last but not least, we also provide out of the box some Prometheus metrics, so you can easily monitor your API usage. And we'll see all of that. Now, if you're in a bigger organization, the same platform can enable you to create and deploy and maintain several API servers as well as authorization servers. Great. Well, let's have a look.
That's cool. Let's maybe take a breath here shortly, because a couple of questions came in.
Sure.
And maybe we cover them first before we do the demo part.
Sounds good.
David had a question. Actually, David has two questions. Question number one from David is, if you annotate your code, don't you end up tightly coupling your code with the authorization logic?
The Athos annotation is really it's a part of the standard. So you're just tightly coupling whatever you're annotating, I guess. But the function, the Athos, is a function that you can use to make a call to anything else, really. So it is not so tightly coupled in that whatever you call can, which in our case here is our authorization service, makes the decision to let you see whatever you're annotating or not. I think it's that coupling you actually want in order to enforce authorization. I'm not sure if it's really, but the authorization server can be reused by any API out there as well. So it's not so tightly coupled.
Okay.
We'll see
Cool.
that. Hopefully it makes more sense when you see it.
Maybe, exactly. And then he has another question on, and I don't know if you want to go in there, or if this is maybe getting us too far away, but how does GraphQL compare to XACML or Alpha?
Thanks, David. Yeah, right. So XACML is a standard that David actually was part of authoring back a while ago. Yeah, I know the David you mentioned.
Yeah. Okay.
But it's essentially a standard to represent access policies in XML.
Yeah.
But as we'll see, we use relationship-based access control. And whatever you could use to represent a graph could be used to represent relationship-based access control. So it doesn't really compare.
Yeah. Cool. Then there was a question on the security. So I think in the infrastructure or architecture view you showed earlier here, exactly there. How would you say? I mean, I think maybe reply again what you said before, and which security best practice you recommend here for this process.
So right now, the way this works is that we also deploy this into our cloud. So we already apply everything that you need. This is actually deployed. We have an Istio microservice mesh. We have SSL certificates and everything. So we take care of everything. Now, if you wanted to deploy these things in your own cloud, this is all runs on Kubernetes. So we could also deploy these automatically in whatever other cloud. And in those clouds or data centers, we need to apply the same thing, maybe create a virtual private cloud, have certificates, have ideally a mesh or something, maybe proxies to ensure your only the right clients are expected to call the service and things like that.
Cool. All right. I think let's continue from here, and I'll collect the next set of questions
Sure.
for later.
Great. Now, if you wanted to have a look at, I would recommend everybody try out 3Edges for yourself. What you would need as prerequisites is a Neo4j instance. Thankfully, you can get a free Aura instance very, very easily. Just even if you don't know anything about Neo4j, you can just a few clicks and you can get an instance, and then use plugging into 3Edges, and 3Edges can take care of it. That's pretty easy. Also, I posted here a link to our own GitHub where we have some free graph models that we can use to load into 3Edges, and we'll use some of them during this demo right now. So given that,
I did the links in chat, so you
oh
should
great,
be able to click on those.
Okay, so let me log in here. This is the 3Edges. Now, if you first get here, you can easily register. I'm not going to do that, but it's just basically 2 screens, super easy. You get an email, you validate, pretty standard stuff. So once I'm registered, I can actually log in. Oh, sorry, if I type this properly. So what I'm presented here with is the first page, the landing page is organizations. Now, if you're just starting with 3Edges, this will be blank. If you're in a big organization, you may have different teams. For example, you have an HR team, a team doing development or whatever. You can segregate your API servers by organization. One thing we can do here, you can build a standalone server. This is something that you just do for yourself for testing or for development. You don't really want to share it with anyone. Organizations, typically, you'll have several people working on it. So let's create a new API server here. This one, we'll just call it, what I have on this GitHub repository is a couple of models. One is an IoT management model. We'll see that. And another one is a document authorization model. So in that document authorization model, I'm going to manage some digital twins of actual documents and use that to drive authorization. So we'll use that for as an example. So I'll just call this one documents because, I'm super creative. Doc authorization system. And I'm provided with a default randomly generated name here. I don't like this, so I'll call this docs. Now, the first thing that 3Edges will do is we'll check if the DNS name, if the URL is not already taken. And as you can see, it will create it under our own domain. So I'm going to save. It's available. So I'm going to save. This will take some time. So what happens here in the backend, we're automatically deploying some pods in our cloud. We're creating all the networking, the DNS record stuff. So it can take up to 2 to 5 minutes, but we can already start working on it. What you see here, is what we call the canvas. It's an API canvas. It's blank. I have a palette of objects on the left side here that I can use to draw things. So I want to draw a graph model. I can drag things. I can drag another object. I can create relationships. I can say, this is my, a user object. It doesn't matter. Anyway, I can keep going like this. I can here add some properties, like a name, like an ID of some sort, and keep going like that until I have a graph model. So this is a model. It's not actual data, but this model will be used to generate an API, the schema of the GraphQL schema, essentially, as well as the resolvers. But as I said, I have some models already pre-canned, so I'm just going to import one. This is the graph models repo I mentioned. I'm just going to use this doc authorization one and load that up. And as you can see right away, I have this slightly more complex thing that shows up.
Yeah, okay.
So here I can zoom in and out. So let me describe what you see here. So this is, as I mentioned, is a model to manage some documents that are located in folders. So I have some documents that are in folders. Now, folders can contain folders, so I can have a hierarchy of folders. Now, as a user, I have a type of account. Now here, one of the objects from the palette is an enum. If you're a developer, you know what an enum is. What an enum is just a set of pre-canned values. So here I'm defining 3 types of accounts for the user. A user can be a user, a manager, or part of IT, let's say.
Yep.
And some of these accounts will grant some action over documents or over folders, either or. Yep. Right? So you see how that works? Now a user can also be a member of a role, and the role also may grant you some action over a folder or a document. Hopefully that kind of makes sense. What else do I have here? Since we're talking GraphQL, we can do things like creating interfaces. So here I have an interface. This is an interface that represents a person. And I'm saying here, by just dragging, I'm saying that the user is a person. So I've inherited all these properties here from the person interface. I mean, these 4 at least.
I see. Okay.
Yeah. And now you may notice that the interface also has an enum for the countries. Right now, I have just the short list of countries that I've entered here. And so therefore the country here is an enum as well because it's inherited from the interface.
I see. Okay. Yeah.
Now another fun thing you can do with 3Edges, it's a no-code platform. I mean, you could generate this without writing any code, but if you wanted to add some code, you can. You can add custom scripts.
Okay.
So
Yeah.
here, for example, is a little script. Let's say that whenever we create or update our users, we wanted to hash their passwords because we want to store them hashed in the database. Kind of best practice.
Is it?
It is. You don't want to store clear text passwords in your database.
Just to be sure, this was a joke. Yes.
So let's say I'm going to create a little function here that will trigger to hash the password. So here's what the script does. It says that the object's password should be the hash of the password. So whatever is entered, just hash it. And this hash function is actually something we provide out of the box through an object that we call name service for some historical reason. But this service also provides other features such as sending emails, making HTTP requests, or running Cypher directly. So you can do kind of interesting, intricate things here. But in this particular example, we're just hashing the password. And this happens, this is interesting here, on create or update. I wonder why this, I guess this model is kind of a bit corrupt. I should update it. Here we should say on update as well. So you have a series of events. So now that you have the script, you have to tell the system when to run it.
Yeah.
So you run it on these events, like when the object is created, when the object is updated, or after, or all these events. Similarly, down here, I have another script I can show you. This one just sets the date. So whenever we create a document on create, we want to set the creation date. So all we're saying here is that we're setting the creation date on when the document is created. There you go. So that's kind of my model. I'm gonna check now to see if the API.
There was one question, and maybe we can quickly do this. And I think you answered this already, but sure. I would just want to double check. David, again, you could attributes. I can put attributes on the user example, role, department, date of birth, exactly. I think this is what you called properties.
Yes.
Yes.
Yeah, absolutely. Here I just have the role name, but I can add as many of these as I wanted.
Yeah, makes sense. And and Eshwa, the model that Alex is using here is in the GitHub link. So if you click on the GitHub link, you find the various models Alex is showing.
Actually, I have the GitHub here. So right now I just have 3 models, but we'll add more. I'll show you some more just in a second. This is just to illustrate what we can do. So now remember I was deploying this actual API was being deployed as I was speaking to our own cloud. So let's see about the status of that. So if I go back here, let's see, it's checking the process. It's still processing, not quite there yet. So while this is happening, I'm going to show you some other models because I have here some other samples. So here the 3Edges is checking the statuses of all these services, and you'll see the statuses pop up as they come online. If you're interested by any of those models or examples, please shoot me a note, contact me afterwards. You have here, if you're interested in consent management, we have a couple of models here. Kantara is an organization that does standards. So they have a standard called consent management for storing and managing consent. So that's how you would do it in Graph. We have some healthcare use case here. We have some more fun stuff. We have this was done actually during Graph Connect. There was a researcher and a student who was doing bio research on orca populations in the Pacific Northwest. So we did a fun model just to model that. So here I'm going to show you, well, as you can see, we can manage all these services. They're all stopped. except for this one. So I'm going to show you this IoT management model, which is another one that's on GitHub. So this one is kind of a bit simpler than the other one. We have a set of what we're doing here is we manage a set of IoT devices, and in order to access a device, a user needs a license that grants them access to an application that can then manage the devices. These are smart devices that are connected to the web.
Okay.
I mean, some of them are not that smart because they require a gateway. But anyway, that's the idea here. So a user owns a license that grants them an action over an app that manages the device or a gateway. I'm going to get back to this one later on if I have time. But anyway, so what you see here is the server management page where you've seen the first page already. The second page is where you configure your authentication service. This is filled up out of the box when you create a new API server, but I wanted just to show you that you can use an external service such as Auth0 or ForgeRock or whatever you want, something like that, if you wanted to use an external OIDC provider. But we'll just use our own one here. On the authorization side, we have some the authorization service URL here, as well as some parameters. I'll get back to that. Here's where you plug in your database. So here, this particular API uses our own development database. It's a Neo4j cluster. It's a bit older than what you would get with Zora. It's version 4.2, but it also works. So you can test your connection. It's live. And last but not least, here's when you're happy with your model here in the UI, you actually apply it to the deployed API server. So I'm going to update the schema here. And this will take a second while there we go. All our configurations here in our canvas has been applied to these services. So now I can actually navigate to the service. And what you see here is a GraphQL playground. I've already run a few queries with it, but the GraphQL playground is deployed at the address that we just created. Here's the doc, which is the GraphQL documentation for the schema we just created. It matches exactly the model we've done. And based on this, now I can do a few things. Wanted to show one last thing first. We also deploy a UI with the API. That's the dashboard. The UI allows you to manage users, for example, which is quite interesting because when you start, you don't have any users in your API. So nobody can use it. So you need to at least create one user. So in order to do that, I'm going to go back here. We actually generate for you a service account for your API so that you can at least log into this UI and create your first user. So I'm going to copy the service account. It looks like this UI needs to be like this. It doesn't matter. Here, logging in. So this is the API that comes out of the box with deployed also. It's also a microservice. It's deployed with your API service. So here I have access to a few things. My list of users. I only have 2 users right now registered with this API. So only those 2 users can use this API. I can, change their profile things, their passwords, and things like that. I also here, importantly, I have a list of client applications that can use my API. These are actually OpenID Connect clients. We generate these automatically, those 2 ones, but you can create new ones. Like if you have your own app that needs to use this API, you can actually add it. But for example, here you find your typical OpenID client configuration like grant types, response types, etc. You can even use this to get an access token using the client credential grant. And if you wanted, you can even test the API right away. And you don't have to go through all the OIDC flow fun. Anyway, so given that, here we've created some users, we can right away log in as those users. We provide a convenient mutation for logging in. Here I'm going to log in as myself. I'm getting an access token and an ID token, which is expected with an OpenID, and then I can use this access token as an authentication token to use the other devices, the other URLs, APIs. Sorry.
Yeah.
Looks like we're running out of time. I'm just going to show you this database to show you what preloaded this with some data, so I can show you some stuff.
It's no problem. We can run a little bit over this. It's not.
Oh, sure. But I mean, anyway, so simple data. We have a couple of users in red. I've showed you the users in the UI. I've preloaded this with a few. This is the Neo4j database. It's the 4.2. But anyway, it works the same with the latest Aura.
Yeah.
We have some devices in blue. We have some actions in green. We have an app in purple, and then here's a gateway, and these are the licenses. So, for example, user Alex owns a license, a dev license, that grants him write and update firmware actions over this app.
I see.
That then manages these devices. This one's through a gateway, right? So that's my data. So I have those two users. So now let's see if I can, using that access token I got just earlier, I'm going to fetch some data. Oh, this is a deep query. Look at that. Exceeded the query complexity.
Yeah.
We talked about this earlier. So let me remove this, for example. Oh, now I get a list. This is acceptable cost for me. Right?
Yeah.
Now, this one here, let me get that access token again, because I think I lost it. Now I want to get the list of devices. So let me run this. Okay, I get 2 devices out, but I had more devices than 2. Why is that? And that's why I want to show you, because authorization. If I go back to my model, I have a little toggle at the bottom here, and I switch now to the authorization view. Now, in this view, I define my relationship-based access control. Here, I draw, the palette has changed. So now I can overlay over my model the path between the subjects and the resources I'm trying to protect. So the first thing I do here is identify the subject. The subject here is the user, and then identify the things that I'm trying to protect in my graph. The things I'm trying to protect are devices, the gateways, the app itself also. Well, basically everything else. And I'm saying here, I'm highlighting all the paths between the subject and the resources. I'm highlighting all the paths that need to exist in the database between the subject and the resource in order for the subject to see the resource.
Yeah, okay.
So we're doing full relationship-based access control. So those paths need to exist in the database. So if you go back here, if you look at the subject, myself, I'm logged in, and all the devices, I really only can see those 2 devices, right? Because there's no path between me and those 2.
No. Yeah.
So this is as I would expect. I only get those 2 devices. Now, if I logged in, if I logged in as Alice instead and tried the same, so now I'm getting another access token. Here we go. I get no devices.
You get no device. Okay, because Alice it wasn't connected to anything down here.
Exactly.
Yeah.
So the last piece I want to show you here is if I don't have anything at all. So that means authentication failed. I don't even see anything.
You see nothing. Credentials.
Yeah. So we've seen this is authentication. We've seen authorization. We've seen how you can do reback or relationship-based access control with 3Edges. We've seen that 3Edges automatically deploys for you API servers. I'm going to go back to that standalone. Hopefully it's back up now. It's checking the status, processing. Yeah, it takes a while. It was a bit faster earlier.
Well, it's sometimes demo.
Oh, there you go. It's running. Sorry.
Okay. Maybe
you
see
here,
here we go. Yes, works.
It's running. So here, I could actually plug in. I have an Aura instance. I could plug that in here real quick. I don't know if people want to stick around for that, but here, if I have, this is an actual Aura data instance. Okay, the user is also Neo4j, and the password, I have it here, handy. There we go. I can test this. Now I can save. This is my Aura instance, by the way. Again, super easy to get one. Let me go back here. So when this was a brand new service, right, that we created,
Yes.
we haven't not deployed anything to it yet. I'm just going to go to the GraphQL service. Out of the box, there's nothing. The schema is empty. It just has a couple of mutations so that we can update the schema. So that's what I'm going to do now. Takes a second. There we go. So now I'm going to refresh this. And you'll see magically that all those document authorization systems just appeared here.
Yep.
And now I can start using this as I use the other one. And now, as you see, this API dashboard just appeared here as well. And here I can go again and open the dashboard that I showed you earlier with the API server, create users, and start using it. I don't know if you want to see that again, but
yeah. Okay.
there you go. We've come full circle.
Yeah.
I can start and stop the service from here, and there you go. You're off to the races with Aura and GraphQL, and all you have to do is write your client app.
Very cool. Yeah, that was. I mean, that was very, very, very fast. I think to get from this to where we are now, and obviously the it always more. I find it more helpful if you have the visual model builder where you can connect visually connect your different nodes, your users, your devices, your folders, your rights and roles and access pathway. So makes it clearer than in another and in this toggle I like a lot because I mean for this it's very okay. This is your core feature, and then you can even define even let's say for specific roles you can only view certain things, so like this crown jewels kind of connotations, and you toggle it back onto APIs. I would say okay, this is part of a bigger system, but the core of it all is the one where you have to pay attention and you have to actually look closely about okay, is there no error, are users allowed to view the right things, and do they have access to maybe things they shouldn't have access to.
Exactly. So 3Edges is online. You're free to use it. Still free right now. It's we have, if you need this for production systems, we need to talk. But I mean, it's totally available for production systems as well. It's just it might cost us money, therefore we will want to charge for it. That's the only reason.
Absolutely, that's fair.
But otherwise, it's all Kubernetes. You can create as many replicas of any pods. It's auto scaling and all of that. So
great. People can try it. There was a question from Josh on LinkedIn. How does this compare to dgraph? Can you say a few words on that?
Okay, dgraph doesn't have the fancy UI we have. That's for sure. I've looked at that. I don't know if dgraph. I don't think dgraph supports relationship-based access control either. So that's also that. Now, auto deployment, I have to look at it again. I haven't looked at dgraph in a while. I think they probably do auto deployments. But that I would think, I'm not sure about OpenID support as well, if they provide their own OpenID provider or not. But those are the main ones. I mean, the big one really is the graphical interface and the relationship-based access control, which you can do on the interface without writing any code. And scriptability, and then all of that.
Okay, cool. Yeah, I mean, if there are any any more questions, then I'm sure, like it's on the screen here, right? You can reach Alex via email, LinkedIn, Twitter, or GitHub, and discuss more. Like Alex said, it's available. Check it out, give it a try. Together with your free Aura instance, this is basically no cost involved on both sides. You have a free database, and you get the 3Edges for free as well. So to test it out and see how this works for you. And yeah, I think with that we are at the end of the stream today. Thank you very much, Alex, for taking the time for the challenges at the beginning and the demo now. I think that was great. It was good to see. I hope people learned a few things from this. The next, because it fits right now, is I'm doing chapter. I need to quickly check. I think it's chapter 4 already, or is it chapter 3? With Will Lyon, or it's chapter 3 on Thursday, 1st of December. So in 2 days' time, chapter 3 on the full stack GraphQL book. So that is that's happening on Thursday. So if you want, tune in then. And yeah, with that, any final word, Alex?
No, thanks a lot for joining. If you have any questions, feel free to reach out. Pretty open. And yeah, hopefully we'll talk soon again.
Yeah, it would be nice. Thank you all for watching. Thank you for a nice chat today. So yeah, see you on the next stream, and take care, everybody. Bye-bye.
Bye. Bye. Enjoy your day.